Hey there, you 12s. Let's have a look at this problem here. This is for me, it's an abstract, not abstract, but more conceptual understanding here. It's a chain rule problem for both of them, actually. So you have to imagine this equation here. I'm just going to write it over here. Let's say y is equal to f of x all to the power of n. What you have to understand is when I look at that, I'm visualizing something like this. I'm thinking of, imagine if it was an f of x, because that's what's confusing students. That's what intimidates students. I think of that as another variable. So I think of it like, let's say u. So I say, let u equal to f of x. Now, if you do that, you see your equation now becomes y is equal to u to the power of n. Now, doesn't that look much less intimidating? You know, you simply look at that and say, oh, well, if I were to differentiate that, how would you differentiate that? And you would say, well, I would do delta y delta u, and using power rule, I can say, well, it's the power multiplied to u to the power of n minus 1, right? That's what you would have said. And the thing is, what I've done is I introduced a third variable to make my life easier. So you can see here, this is my delta y delta u. What am I really trying to find is I'm actually trying to find delta y, so change in y and the change in x in this case. Okay, so I'm really just using a chain rule. I'm just using delta y delta u multiplied to delta u delta x. So I've got delta y delta u. My job is to find what delta u delta x is, which coincidentally, because I replaced it, the f of x with the variable u, which is what I made up with, I can find delta u delta x there. So here we go. I say, all right, well, delta u delta x will then have to be the derivative of f of x, which I don't know what it is. It doesn't matter what function it is. It's going to be f dash of x. True, because that's the notation for the derivative of f of x. So whatever f of x is, f dash of x is the derivative. So that gives me now my second part that I needed. I needed delta y delta u, and I needed delta u delta x, which I now have. So putting them both together, this now gives me the equation n times u to the power of n minus 1, which is delta y delta u, multiplied to f dash of x. But since this is delta y in terms of delta x, I can't have that letter u. The u is a made-up variable. I made that up to make my life easier. So in this case here, you have to replace what u was, and u was f of x. So coming back here, I'd say then that's n multiplied to f of x to the power of n minus 1 multiplied to f dash of x. There you go. So what it's trying to say is that no matter what the function is, we don't know what f of x is right now, but no matter what it is, the derivative for a sum function, whatever kind of function you have, to the power of n, you can find that by multiplying n, which is the power, whatever the function is, to the power of n minus 1, and then times it by the derivative of f of x. And that's essentially how I do my chain rule. When I look at a problem as an example, if I gave you y equals to cos cube of, I'll just make it easy for now. So let's just do that. That's essentially the same thing as saying, I want you to find the derivative of cos of x all cubed. Now, according to this formula here, in my mind, f of x is the cos of x. So when I find the derivative, I do it all in one go because I can see what I need to differentiate. I've got the n, which is 3, multiplied to the derivative of cos to the power of 3 minus 1, right, which is 2. And derivative cos, f of x currently is cos of x there. And then the derivative of cos is negative sine of x. Can you see there? This is my n. This is my f of x. This is my n minus 1 according to the rule. And then this is my f dash of x. That's my chain rule. So you can do something like this all in one go. If you understand how chain rule works, that's how my sort of mindset works. When I look at those type of problems, I can differentiate them very quickly. Okay, so in this question here, it's actually getting you to understand how to work with, it doesn't matter what function you get, it's to give you the overall understanding. So if you have a look at B will be quite similar in the same respect of what I was doing just now. If you do B is say y equals to 1 on f of x, right? Then it's the same drill here. I would then rewrite it as y is equal to f of x to the power of -1. And the same drill again. Okay, so I would make it easier for myself by saying let u equal to f of x. So that means I will need to find delta u delta x for this one, which is pretty easy, f dash of x. And then since I replaced it with a u, this now becomes y is equal to u to the power of -1. And so if you were to find the derivative, this one is nice and easier. Delta y delta u is equal to -1u to the power of -1 minus 1, which is -1u -2. Okay, and so then the chain rule says, well, if you wanted to find delta y delta x, multiply delta y delta u with delta u delta x. And that gives me -1u to the power of -2 multiplied to f dash of x. And putting them all together, since it's meant to be in terms of x, I need to replace that u, and remember u was equal to f of x. So putting them together, that's -1 times f of x all to the power of -2 times f dash of x. Now, rule of thumb is in year 12, you should never leave your answers with negative powers. So I would rewrite that as -1 all over f of x squared multiplied to f dash of x, which another way of writing it is negative of the derivative divided by the function squared is my derivative. Okay, so that's how you would solve that problem for both of them. It's really just getting you to use chain rule.